Now let's summarize some very important points about probability. The probability of an event A, notated the P probability of A with the A in parentheses, is a ratio between 0 and 1 inclusive. So let's talk about what we mean. We've said before that the probability of event A under the relative frequency approximation was the number of times A occurred over the number of times the procedure was repeated. It's a ratio. That was the relative frequency approximation. Let me make a note of that. So this is relative frequency approximation. And then I'll go ahead and just show the other calculation we used was the number of ways A can occur over the number of different simple events. And this was the classical approach. But now when we look at these, O-A-C-H, okay, let's think about the statement that the probability of an event A is a ratio. Okay, these are ratios, they're fractions, as we see both of these are, a ratio of A to B, a numerator to a denominator, between 0 and 1 inclusive. What does that mean? Well, let's think about the numerator. Can the number of times A occur ever be larger than the number of times the procedure was repeated? Could this numerator ever be larger than the denominator? Well, of course not, because A can't occur more than the number of times you run the procedure. Likewise, the number of ways A can occur cannot be larger than the number of different simple events that are in the sample space. So we can see that it would be impossible to ever have a numerator larger than a denominator and therefore get a probability larger than 1. Now, we could have a probability of 1. If the number of times A occurred was every single time we ran the procedure, these two would be the same, and that would be 1. But that's the highest possible value for a probability. So we can clearly see why 1 is the highest possible probability, and nothing larger than that would represent a probability. That's what this inclusive means. It could be 1 or it could be 0 and everything in between. Now, could it be less than 0? Well, for that to happen, this numerator would have to be less than 0, right? We'd have to somehow get a negative number out of this. And how could we possibly do that? Numbers less than 0 are negative numbers, and that's not going to happen with these calculations. So it just makes sense that probabilities are numbers that are between 0 and 1 inclusive, and there's no way to get a value larger than 1 because A can't occur more times than you run the procedure, or you can't have more ways of A occurring more than the number of possible simple events in your sample space. It's not going to happen. So it's very obvious that we can't go larger than 1 and that this cannot be a negative number. So that's how we understand the probability of an event is a ratio between 0 and 1 inclusive. Another way you'll see that written is the probability of event A is less than or equal to 1, but greater than or equal to 0. Okay, another important point about probability is that the probability of a certain event is 1. So when we do calculate a probability of 1, it's because that event is certain. And this is not common, and it's certainly not an interesting probability. If something we know is going to happen, we're not terribly interested in that procedure or that event. For example, the probability that Labor Day will be on a Monday this year is certain. Why would we calculate the probability of Labor Day falling on a Monday? But the probability that Christmas falls on a Monday might be of interest. So, or the 4th of July. What's the probability that the 4th of July is on a Monday? That would be something you could calculate a probability for, but not something, but if it's certain, such as Labor Day on a Monday, that probability is 1. And the probability of an impossible event is 0. So I could say the probability of Labor Day falling on a Wednesday is 0, because that's just not the way that holiday is scheduled. So that would be considered an impossible event. Again, not of interest. We're usually looking for probabilities somewhere in between these two. We're usually looking at situations that have a probability that falls between these two. Another important point about probability is that the sum of the probabilities in a sample space is 1. So let's look at an example to understand that, or a few examples. We've seen, or we've talked about a case where we might be flipping a coin. And so our sample space here would be either we got heads or we got tails. And so the probability of heads plus the probability of tails should equal 1. So the probability of heads, from what we understand about the sample space on a fair coin is that there's one way to get a head out of 2 possible outcomes. Same for probability of tails, one way to get a tail out of 2 possible outcomes, and so that equals 1. Or the sample space where we are rolling a fair die. So our outcomes are the numbers 1 through 6, right? So the probability of a 1 plus the probability of a 2 plus the probability of rolling a 3 plus the probability of rolling a 4 plus the probability of rolling a 5 plus the probability of rolling a 6 should be equal to 1. And what we understand about the sample space when we're talking about rolling a fair die is that there is one way to get a 1 out of 6 possible outcomes, and one way to get a 2 out of 6 possible outcomes. These are equally likely events. It doesn't matter if they're equally likely or not, you still should get 1 when you add up all the probabilities in the sample space. So of course we have 1/6 6 times, so we have 6 6 or 1. Now this only makes sense because if we got something less than 1, that would tell us that we're missing something from our sample space. If I just had the numbers 1 through 5 here, then I would have an error, and I could catch that. But when you add these up, you should get 1. Now if there's been some rounding in your probabilities, this could be off just by a rounding amount. You could get 1.001, but if that's just due to rounding, that's fine. Or 0.999, that would be a rounding thing, and that's fine. But the sum of the probabilities in your sample space should be 1. Another important point about probability. And then lastly, an event is considered to be unusual if its probability is less than or equal to 0.05. Now that can change, but this is the most common number that's used. But you know, we will see as we get further into the course that sometimes we'll consider unusual maybe something smaller than that. But what this means is 5% of the time. If this is something that occurs 5% of the time or less, then that's considered to be an unusual event. And like I said, that could change, but this is the standard most of the time. If you're not told what to use for this, what is unusual, then you would this would be the standard to use, 0.05. So quickly, our review of our summary about probability, all very important points about probability, and once you understand these, that'll really help as you continue on through the course.